All right, last section from this unit is our unit B. Our second test is coming up, and we are going to talk now about some operations of functions. So we've dealt with our first 4 sections, all different attributes of graphs. We did a little bit of solving in section 2.4 with absolute value stuff. And so now we're going to talk about operations of functions. There's 5 operations of functions, okay? I think the first 4 are going to be stuff that is super familiar to you. It's going to look pretty much like stuff you've done in the past. In other algebra classes, I don't think it's going to be too big of a deal. So what I'm going to do first is I'm going to summarize the first 4 of the 5, and we're going to just do a bunch of examples of them and see how that goes. So if I'm given 2 functions, function f and function g, for all values of x for which both function f and g are defined, we have the following 4 operations. So this is just going to tell us what we can do with different functions. So this first one is called the addition function. It is not going to wow you at all. It's going to be exactly what you think the addition function is going to be. It says if you have a function that is created by adding 2 functions, f plus g, then all you do to create that is you take function f of x and then you add function g of x to that. And after I define these first 4 operations, we're just going to go through some examples, and we're going to do some examples with the functions themselves. We're going to do some examples that have numbers. Okay, so just to get you used to doing these 4 things. The same thing, again, I don't think any of these things are going to rock your world. The difference function, f minus g, well, what that means is I can take the first function f and subtract whatever the second function g is. All this is telling us, I know it seems intuitive to you. On the back end, if you were a mathematician, to prove these things takes a little bit of doing, but it's just telling you we're the beneficiary of, we can separate and treat these functions as individuals. Okay, that's what the point of this is. The product function, f times g, again, I can take function f and I can just multiply by function g or whatever its value. So there's no mysteries, there's no other terms. And then finally, the quotient function is f of x divided by g of x. There's one caveat to the quotient function, though, that we have to be careful of. Since we're now dividing, we are going to eliminate anything that causes g of x to be equal to 0. So we are going to, any inputs that make g of x 0 because it's in the denominator, we're going to eliminate. So there's a domain restriction on the quotient function. We'll deal with that a little bit in here. Grab your packet right there. We'll deal with that a little bit in here, but when we get to units, it's either, I think it's unit D, the 4th unit, we'll talk about that a lot more. Okay, so that was super fun. I'm sure you're enthralled right now. Now we're going to get to some examples. First, we've got examples that deal with numbers. So here we go. I've got function f is defined by the absolute value of 2x plus 1. The function g is defined by x squared. And my example that I'm going to do is, what is f plus g of 2? Well, according to the way we've just defined things, what I'm going to do is I'm going to treat each function individually, and we're going to figure out what the function value of f at 2 is, and then we're going to add it to the function value of g at 2. So all we're doing is we're plugging in the value into each individual function, and then we're going to add up the results. So as much work as you need to write down, I know some of you are a different level on the curve as others, that's fine. I just want to respect everyone, so I'm just going to do a little extra writing. So function f is 2 times x plus 1, and then function g is x squared. Now I've just left a blank instead of putting the x's, which is my habit. And now I'm going to put in the value 2, because that is the value we're plugging in. And now it's just arithmetic once I've set that up. So in my absolute value, 2 times 2 is 4. 4 plus 1 is 5. So I'll write down that that's the absolute value of 5. I won't skip all the steps. The second function, 2 squared, 2 times 2 is 4. And so then my value of the addition function, f plus g of 2, is the absolute value of 5 plus 4, that is 9. Any mystery? Anybody cause for concern? So what I'm going to have you do is with these same two functions, I'm just going to have you go through and do each of the add, subtract, multiply, and divide, just so that you get the feel for it. So go ahead and do exercise 1. It's basically the same thing, but instead of a function value 2, you're doing it for function value -5. All right, so this first one is the addition function. And if you're working ahead, that's great, but we'll go one at a time. So again, the addition function says that in order to figure out this addition function, I can take the function f and evaluate it at -5, and then evaluate the function g at -5. Okay, we can treat them individually. And so in my first function, it's the absolute value. So the function f is 2 times whatever I'm plugging in plus 1. And then g is whatever I'm plugging in squared, and what I'm plugging in is -5 into both of those spots. So in the absolute value, 2 times -5 is -10, plus 1, that's -9 with an absolute value around it. -5 squared, -5 times -5 is +25. Absolute value of -9 is 9, plus 25 is 34. And that is my function value. Did anybody get anything different that you don't understand why we got something different? If you caught your mistake, that's great. Yeah. 2 times 5 is -10. -10 plus 1 is -9. Absolute value of -9 is 9. Yes, ma'am. Absolute value makes everything positive. Yes, it's just the value. Perfect. All right, any other questions? Absolute value makes every number inside of it positive, but you have to do your operation first. Okay, so if you have the -10 plus 1, you can't make that -10 positive at that point. You have to, it's like order of operations. You do what's in there first, and then you get your value. Okay, great questions. Thanks for asking it. Okay, same thing with this next one, example 2. Do that. Now we're doing the difference function though. Same steps, just now instead of adding the two values you get, you're going to be subtracting them. I'm going to get started. If you're still working, keep working. So I've got my function f. I'm going to evaluate it at 8, and then I'm going to subtract my function g, evaluated at 8. Again, all these operations are saying, hopefully you catch on to this at some point, all these operations are saying that we went through at the top is in everything you do, you can consider the two functions separately. That's really all it's saying. Okay, so I've got f minus g of 8. My function f is the absolute value of 2 times whatever I'm plugging in plus 1. And then my function g is whatever I'm plugging in squared. And in this case, we're plugging 8 into both of those spots. So when I do my arithmetic inside the absolute value, 2 times 8 is 16, plus 1 is 17, so I have the absolute value of 17. This time I'm subtracting, and 8 squared, 8 times 8 is 64. I'm not squaring the negative. The negative is not being squared. There's no parentheses around it. That's a subtraction sign. And so the absolute value of 17 is 17, minus 64 is that negative 47? Thank you. It's a little early for doing arithmetic in our head, but I succeeded there. Okay, we're just going through one of each. Do the f times g of 4, please, the multiplication function. So f times g of 4 is going to be the function f evaluated at 4. This time I'm multiplying the function g evaluated at 4. The function f is the absolute value of 2 times whatever I'm plugging in plus 1. The function g is whatever I'm plugging in squared. And in both cases, I'm plugging in the number 4. 2 times 4 is 8, plus 1 is 9. That's the absolute value of 9. Times 4 is 16. Absolute value of 9 is 9 times 16, and that is something like 144. Boom. Thank you for your confidence. I love it. All right, one more of these with numbers. And if you have any questions, let me know. Hopefully this is sinking in. The first 4 operations I don't think are too bad. Do the division problem, please. So I'm going to get started. I'm going to take the function f. I'm going to evaluate it 2. I'm going to take the function g. I'm going to evaluate it at 2. The function f is the absolute value of 2 times whatever I'm plugging in plus 1. Function g is whatever I'm plugging in squared. And in both cases, I'm going to plug 2 in. So in the numerator, 2 times 2 is 4, plus 1 is 5. So that's the absolute value of 5. In the bottom, 2 squared is 4. And so I end up with just 5 over 4. If you're a fan of decimals, 1.25 is an acceptable answer. Do you see the gist of what's going on? Anybody not grasp on to we're just doing each function individually? Are we good with it so far? Okay. Well, when we do it with variables, it doesn't really get any harder. So we're just going to do a few examples here. I've changed the functions just to keep us awake. So I've got 2 new functions. I'm going to do the sum function here. So again, I'm going to take my function f of x. Okay, so this time I'm not doing it for a particular value. I'm doing it for all values of x. And then I've got g of x. And now it's just a matter of substituting the functions like we were doing earlier when we put in our values. So in this case, f of x is x squared plus 5x. plus g of x is 2x minus 7. And so my new function, the addition function that I could, if I just wanted to graph this instead of graphing both of these functions separately, is what you get when you do any sort of simplifying. Now, some of them you won't be able to simplify anything. Others you'll be able to do a little bit. Like on this one, we can collect some like terms. So I've got x squared, and then 5x plus 2x is 7x, and then minus 7. So now for any particular value, if I was asked to do f plus g of 4, you could just plug 4 into the new one instead of doing it to each separate one, okay? Because now we've combined them. Do the same thing for exercise 5. Notice I've reversed the orders of the functions, and it is a subtraction problem. So be careful with your signs on that one. That's why I put this one here. It's always something that causes us a little trauma. So this time it's g of x minus f of x. So the function g is 2x minus 7. Okay, so if you missed this next part, I totally get it. Just make sure, take this opportunity to learn. When we got that subtraction there, we've got to make sure that we subtract everything that comes next. So to remind myself of that, I'm going to put some parentheses to say I'm subtracting everything that comes after this. And so that is x squared plus 5x. So sometimes what students will forget to do is they'll forget to attach that minus sign and distribute it to the 5x, so you'll get the wrong middle term. Okay, so just be careful. So again, if you miss that, don't beat yourself up, don't shame yourself, just learn from it. And remember next time, because you're going to see more subtraction functions on your homework and the test. All right, so I'm gonna distribute that minus sign. A negative times x squared is negative x squared. A negative times 5x is negative 5x. I like to put my terms in descending order. It's not mandatory. It's just helpful as we go along. So I'm going to put that negative x squared first. The 2x minus 5x is negative 3x, and then minus 7. As long as you have those three terms in whatever order, doesn't matter. I just put mine in descending order. All right, we're going to flip the page. We are going to use these same two functions. I think we're going to do 2 more. And then we're not going to do every one of the next example just because of time. So we're going to still use x squared plus 5x and 2x minus 7. I would like you to please do exercise 6. Do the multiplication function. We get to review a little bit of our favorite math acronym, FOIL. Yeah. All right, so f of x times g of x, my function f of x is x squared, and then I forgot because short-term memory problems when you get old, plus 5x, and then g of x is 2x minus 7, I'm pretty sure, but now I'm not confident. There it is. Okay, so there's you're basically done with the problem. Now the rest is just simplifying. Okay, you've accurately put down the product function if you've written down what I have there. Now I just have to make this look a little prettier. So I am going to do some foiling. My first outers, inners, last, a little introductory algebra. So hopefully you remember this. It was 2 classes ago in your algebra life, but if not, here we go. Quick review. X squared times 2x is 2x to the third. That's my firsts. My outers, x squared times negative 7x is negative 7x squared. My inners, 5x times 2x is 10x squared. And then my lasts, 5x times negative 7 is negative 35x. I've got one more thing to do. That's 2x cubed. I'm going to collect these like terms in the middle and get 3x squared and then minus 35x. And that is my answer. That's the product function. Okay, so exercise 7. Then we'll have worked our way all the way through all 4 operations. I would like you to just tell me what the quotient function is. That should be super easy. That should take you 10 seconds because there's not really anything you can do. But the harder part to this is what's the domain? Okay, and so if you struggle with the domain, that's the thing we're going to learn. Bless you. Okay, so if you don't remember finding the domain from your intermediate algebra class, okay, because that's something we cover in there, that's okay. We're gonna go through it again when we go to rational functions a little later, and this gives us a quick opportunity to review a nice basic rational function right here. So first off, we're done. This is the quotient function right here. F of x is in the top. G of x is in the bottom. There's absolutely nothing I can simplify there, so there's not a whole lot of work. The work involved in this one is about the question of domain. So if you remember, maybe it'll come to you as we go through this, with our fractions, we cannot have 0 in the denominator. So any input, any x value that creates 0 in the denominator, I have to exclude. So here's the way I do this. This is the way I teach my students intermediate algebra. I don't know if any of you had me online or anything like that. So we have 2x minus 7, and we just say, okay, that can't be 0. Okay, because I can't divide by 0. My denominator never can be 0. So I just solved this now. I'm going to add 7 to both sides, and I'm going to get, okay, well, that means the 2x can't be 7. And then I'm going to divide by 2, and that means the x can't be 7/2. Again, we talk about this in intermediate algebra, but it may have been a long time for you. So how do I now write the domain if x can't be 7/2? Well, first, remind me this. Okay, we did talk about this part in this class. How do you write all real numbers as an interval? Negative infinity to positive infinity. So what I'm going to do is I'm going to write a negative infinity. I'm going to leave a big gap, and I'm going to put my positive infinity over there. So that's all real numbers, negative infinity to positive infinity. But now what I have to notate is I need to hop over 7/2. 7/2 is a blip on the radar. I can't use it. So what that means is that number 7/2 now cuts my number line into 2 parts. It cuts it into the first part of negative infinity to 7/2 with a parenthesis, not a bracket, because we don't have equality. Does anyone remember what I put between the 2 intervals that we have? Not a comma. I understand the confusion because there's new notation. We use commas when we're listing increasing and decreasing and constant intervals. We use it when we're doing intervals of continuity. But for domain, because this is all one set joined together, we use a U for union. Okay, that means that's like linking the train together. And then on the other side, we say, okay, now we're going from 7/2, comma, to infinity. We'll do another quotient function because I want you to practice that again. That's an important skill that I want you to remember, finding the domain. But before we do that, I'm going to change up the functions. So f of x is now going to be the absolute value of x plus 9. G of x is 5x minus 8. I'd like you to make your best hypothesis about what you think the addition function is going to be. Okay, I'm not going to let you think too hard and long on this because it's probably easier than some of you are making it. You just might not be remembering how absolute value works. So my addition function is f of x plus g of x. Well, f of x is the absolute value of x plus 9 plus g of x is 5x minus 8. And then here's the thing. This x plus 9 is an absolute value. I can't add the x and the 5x. That's outside the absolute value. I'm done. Okay, there's no simplifying that I can do on that problem. So if you tried to go any further, just cross out anything you did afterward and just make yourself a little note that absolute value, it's not like parentheses. If we had a number, we could do something more, but we can't do anything more without knowing a particular value. Okay, so maybe you did try to go further than that, and that's okay. Let's take that learning to the next exercise 10, the product function. Write down what you think the product function is going to be. Okay, again, I'm not going to give you too long to think about this because I don't want you making it harder than it has to be. So my product function is f of x times g of x. I can consider the functions individually. And we saw up above, it's not on the screen, but you can see it on your paper, that f of x is the absolute value of x plus 9. Again, that absolute value times g of x is 5x minus 8. Well, again, I can't FOIL anything, because the x plus 9 is in the absolute value. The absolute value trumps everything. That would be the first thing that you'd have to do. So until you know a value, there's nothing else you can do on this particular problem. Okay, so don't try to go too far and create situations where you're doing more work than you need to. Okay, the last problem like this we're going to do, and then we'll be just about done with the first 4 of our basic operations, is do exercise 11. It's a quotient function. Again, the quotient function should be super simple for you to take care of, but the domain is the tricky part of this one. Okay, so the first part of this is what is the quotient function? Well, the quotient function is simply what you get when you do the function f in the top and the function g in the bottom, which is the absolute value of x plus 9 in the top, 5x minus 8 in the bottom. Done. There's nothing else to do there. Okay, but what I need to do now is answer this question, what's the domain? The domain fully relies on the denominator of this. So the domain is what I get when 5x minus 8 would be 0. I don't want it to be 0. I add 8 to both sides, so the 5x can't be equal to 8. Divide by 5, the x can't be equal to 8 over 5. So I'll now write that in interval notation. If you got that far, you've done a wonderful job. The last little bit is now to write it in interval notation. So negative infinity to infinity is what I started out with. And now I have to just say I'm excluding this value. I'm hopping over it. So we go from negative infinity to 8/5, parenthesis, not a bracket. Bracket means equality, and that would mean you're leaving that value in accidentally. Union, 8/5, comma, infinity. All right, one more little thing to do.
So do you do the equal 0 for every?
Yes, in the denominator. If you're asked to find out what the domain is when the bottom is 0. And so the way I've written it is the bottom can't be 0. I want to avoid this, whatever value makes this 0. And right now, like, I'm not assuming you remember too much because we're going to talk about quadratics again later in the class. I don't remember the homework. I think I picked out anything that would be anything more than a linear function in the denominator. That's my expectation of you at this moment. Okay, so if there's something more than that in the homework, I'm sorry. Sometimes the test or the problem bank pulls things in that I'm not expecting. I'm not trying to make your life harder than it needs to be. All right, last thing is where we're going to end here. This is very similar to where we started. We've got functions, but instead of defining the functions with an actual equation, what I've got here is I've defined the functions with the graph. So we're just going to do a couple of these. I'm gonna start. Reading the graph is super important. So what we're going to do is using the graph, we're going to find what f plus g of 2 is. So that means I'm going to find out the value of f at 2. I'm going to add it to the value of g at 2. Well, just to make sure we're all awake and have had enough coffee today, the 2 in the parentheses, that represents what value? Where am I going to look? The x value. So I'm going to come down here to the graph. I'm going to make a little mark just to remind myself at the x value 2. And now, what's the value of f at that x value? 1, 2, 3, 4. Yep. What's the value of g at that x value? 1, 2, 3, 4, 5, 6 downwards. So -6 is indeed the right answer. And so 4 plus -6 is -2. So what I would like you to do, please, is just to do the difference function and do the quotient function, and then we'll be done with these problems. All right, so the first one is g minus f at -1. So that's going to be my value of g at -1 minus the value of f at -1. So I'm going to come over here to -1. I'm going to make a little mark with my purple pen. So G at -1 is 1, 2, 3 downward, so -3. Then I'm subtracting. F at -1 is 1. So -3 minus 1 is -4. That's the value when I combine those functions using subtraction. Last but not least, the quotient function. G divided by F at 1 is going to be the value of G at the X value 1 divided by F at the X value 1. So G at the X value 1, here's the X value 1 with my black marker. G at the X value 1 is 1, 2, 3, 4, 5 downward, so -5. F at the value 1 is 1, 2, 3 upward, so +3. And that's what it is. It's -5/3. All right, so that is the first 4 of our basic functions, the add, subtract, multiply, and divide. Any crises that you're having right now before we turn to the last function operation, the 5th one? This one's the one that's probably going to be new to most of you. All right, flipping the page, super excited for new information. The last function operation is called function composition. Okay, we are going to compose functions. If you are going in, I know some of you in this class, you are math terminal and you are just surviving till the end, and that's awesome. Good for you. Some of you, though, you're going to pre-calculus after this. You are going to see composition a lot in that class. Okay, this is something that gets used over and over. It's very useful as far as how functions operate. So what is function composition? Well, that's why I'm here. If f and g are functions, then the composition of function f and function g, here's the notation. F, a little circle, it's not the letter O, but it's not a multiplication dot. Okay, so it's just a little circle. F composed with g of x. That's the notation. Now, we don't like that notation because it doesn't really tell us what to do. So that's going to be equal to, so this is f. When you're reading this, you would say f, this circle means f composed with g. Okay, so if you want to make a little note to yourself, if you haven't seen this before, that would be the way you would speak it. F composed with g. Now I'm going to put it into a notation that might be a little more easy to assimilate. And so what I'm going to do is you go in the same order that the functions are here. F comes first in what I've got, so I'm going to put an F. But instead of the composed with symbol, what that means is I'm taking the function f and I'm plugging the function g into it. That's my function notation for what the composition is. Bless you. So I know you probably haven't seen this before, so I've got a whole bunch of examples, and we've got 40 minutes to do them. So we've got plenty of time to do some repetition here and get sort of a little more comfortable. So like we did with the other operations, we're going to start with values first. Okay, so I'm going to do this example. My function f of x is 2x plus 5. My function g of x is x squared. And I want to know, what is f composed with g of 3? So first thing I'm going to do, because the composed with this symbolism doesn't really do much for me, so I'm going to immediately change the symbolism to function notation. I'm going to say this is f, and I'm composing it with g of 3. I'm plugging g of 3 into it. Now, if you need to, on this first problem, I'm going to do some scrap work on the side. The first thing I need to figure out is, what is the function value of g at 3? That's what this is telling me. Basically, it's like you're nesting the functions. You're going to do the first function, and then you're going to work your way out. So first thing is, what is g of 3? So I'm going to come over here to the side, just so that you know, g of 3 is equal to, well, the function g is whatever you're plugging in squared. So this is 3 squared, so that is 9. Everybody with me on what g of 3 is by plugging 3 into the function x squared?
Yeah.
So what function composition simply means to do, I know this is difficult, it's the first time you've seen it. I'm now going to take that output, that g of 3, and it's going to be what I plug into the function f. So the first thing I did was I evaluated g at the value 3. I got 9, and that's now going to be the value that I plug into the function f. We're working our way outward. And so now the function f evaluated at 9 is 2 times whatever I'm plugging in plus 5. And what I'm plugging in is 9. So 2 times 9 is 18 plus 5 is 23. That's what I get when I compose those two functions at the value 3. 23. That is the answer. All right, so your first problem, same problem, just a different value you're plugging in. So exercise 13, f composed with g, so you're doing the functions in the same order I just did it, but this time you're doing it at -2. Okay, so again, the first thing I'm going to do is change the notation. I never work with function composition. It looks like this. This just tells me what to do. So the first thing I'm going to do is do f, and then I'm going to plug g of -2 in. Notice I keep the functions in the same order. F, then g, then -2. F, then g, then -2. Just stressing that for the next problem when I reverse the order, because I don't want you to miss that detail. So okay, if you need to on your scrap work, what is g evaluated at -2? What do you get when you plug -2 into this function right here? 4. So now I'm going to plug 4. Notice, as you're doing your notation, comparing what you have written with what I have, once you do g of -2, there's no more g in here. You don't need it anymore. Okay, you've performed that operation. And now I have f of 4. And so when I plug 4 into this function, 2 times 4 is 8, plus 5 is 13. We doing okay? I know this is new and different. Sometimes can make you feel a little dizzy. That's why we're practicing. Okay, next one. I'm reversing the order of the functions. G of f of -2. I've kept the value the same, but I've flipped the order of the functions around on this problem. Okay, so this time with the order the functions are, the function f is the one that's inside. Okay, g comes first, then f, then -2. So here g comes first, then f, then -2. So that tells me this time I'm doing the function value of f at -2. So when I put -2 up into the function f, 2 times -2 is -4, plus the 5 is, I think I heard you say 1, or maybe I'm just imagining things, but 1. Whoops. There we go. And now I'm going to take 1, I'm going to plug it into the outside function, into the function g, and g of 1, when I square 1, I get 1. We doing okay? Okay, we're not going to do all the problems in the next example, but we're going to do a couple of them. I've changed the functions. So what I would like you to do is on this one, do we'll do exercise 15 in a minute. We'll do that one together, but I would like you to do exercise 16. Start there. Okay, so this says to take g and compose it with f of 1. So again, with this order, my function f is the inside function. So I'm going to take the value of 1 and I'm going to plug it into the function f. So when I come up here, when I plug 1 in, 5 times 1 is 5, plus 4 is 9. So now I'm going to take the value 9 and I'm going to plug it into g. So when I plug 9 into g, up here, 9 plus 1 is 10, and that is under my square root. Oops, which you can't see, sorry, which is under my square root. 10 is not a value that I can simplify anymore. 10 is 5 times 2. Neither of those things are a perfect square, so that is the answer. Don't do anything else. Don't put it in your calculator. I don't want approximation. We're good with the exact answer. I'm going to go back to the previous exercise. I put this one on here because I had a point to make. So I'm going to get started with it. So the first step is it's f of g of -2. And here's the point that I wanted to make about this one. When I put -2 up in under the square root, what do I get under the square root? -2 plus 1 becomes what? -1. Now we are dealing with functions where in the Cartesian coordinate system, is square root of -1 something that is defined? No. So I'm just going to write up here that the square root of -2, or excuse me, g of -2 is the square root of -1. At this point in time, we're not dealing with stuff like that. So when you get something that, whether it's in a fraction or something like that, your answer here is going to be that that is undefined. Well, I seem to be getting a lot of positive response about plugging in values, so that's good, and you'll get some practice on your homework. So the next thing, and we'll do a couple more with values on the back page. I've got some graphs there, but this is probably the big thing for the day, the hardest thing. So for these next 4 examples, I'm going to slow down just a little bit, make sure that this sinks in where it needs to. So now we're going to do f composed with g, but this time not for a particular value. We're going to do it for any value. We're going to see what is this new function that I'm creating. So first step, I'm going to take f and I'm going to plug g of x in. This is how I like to do the problem. I'm showing you my steps, the way my brain works. And so if this works for you, it's my hope that I'm breaking this down simple enough that you can catch on. First thing I like to do is I like to substitute whatever g of x is into the function notation. So instead of a g of x here, what am I going to write inside the parentheses? What is g of x? Okay, it's the square root of x plus 1. So I've just done a simple substitution there. I've done absolutely no calculating or simplifying or anything. There's nothing like that to do. Now, step 2, I'm going to do with the function f what I do when we plug in values. You've seen me do it. The function f is 5 times x plus 4. So that is 5 times x. So whatever I'm plugging in, I just put some parentheses there instead of the x, plus 4. You tracking with me on why I got those parentheses there? Because that's where I'm plugging in my new value. But this time my new value is not a number. My new value is a function. So that is going to be square root of x plus 1. Now, there's not really anything to do here. I'm gonna erase those parentheses just to make it look a little simpler, but I can't distribute the 5 because you can't multiply the 5 times the stuff under the square root because one bit of it's outside the square root, one bit of it's under. So this is the function, 5 times the square root of x plus 1, and then the plus 4 is outside. All right, so I know that's tough, that's difficult. This is a big thing, a big concept, the new thing for the day. I would like you to use these same two functions, but compose it g composed with f this time. You're reversing the order of the two. So we've got g composed with f of x. Okay, again, notice my order. So my function notation says I'm going to plug f of x into the function g. So I'm going to start with g, and then I'm going to, in my parentheses, instead of having an f of x here, I'm going to substitute what f of x is. And f of x is 5x plus 4. So now in the function g, I am going to plug in that. So we'll worry about that in a second. The function g up here, just off the screen, is the square root of x plus 1. So it's the square root of x. So I'm going to put parentheses there for the x plus 1. And inside those parentheses, this represents the x. That's where I'm plugging in my new thing, and my new thing is 5x plus 4. There's one little thing I can do on this one. I do have a pair of like terms under there. So when I compose this, I've got square root of 5x, and then 4 plus 1 is plus 5. All right, down below, I have changed the functions. Same things, though. So I would like you to do exercise 18 with these two new functions, f composed with g of x. All right, so I have f composed with g of x. So again, I'm going to take my function f, and inside the parentheses, instead of having a g of x there, I'm going to plug in what that function is. And that function is x squared minus 2. So now what I'm going to do is I'm going to write down what the function f is, and I'm going to leave a space wherever I'm supposed to plug in my value. So the function f is x plus 3. So the function f is x, so that's where I'm plugging something in, plus 3. And what I'm plugging in is x squared minus 2. Oh, I just have a little bit to simplify here, not too big of a deal. So I have x squared, and then the negative 2 plus 3 is plus 1. There's my new function that represents what I would get as I go through my x values and I compose g of x and f of x. One more of these. So if you got a question, comment, or concern, this is a great time to bring it up. I'm reversing the order. There is a little bit of foiling to do in this next one. Okay, so you can go ahead and do that simplifying. So same two functions, but g composed with f in exercise 19. So here we have g composed with f of x. So g is the first function. This time I'm plugging in f of x, and f of x is x plus 3. So I'm going to put that in my parentheses right there, x plus 3. So now I'm going to go through with the function g, and I'm going to leave a gap wherever my variable is. So the function g is x squared minus 2. So it is x squared. So x, what I'm plugging in, squared minus 2. And what I'm plugging in is x plus 3. So if you got to this point, you've done a wonderful and incredible job. You've done the new bit, the college algebra. The rest of this is a little bit of introductory algebra that you might need to refresh on. So I've got my x plus 3 squared. Just going to come over here down to the bottom and do a little scrap work. X plus 3 squared is x plus 3 times x plus 3. Do my foiling. Firsts give me x squared. Outers give me 3x. My inners give me 3 more x. My lasts give me 9. And so what I have is x squared. 3x and 3x is 6x plus 9. That is the x plus 3 squared. And then that minus 2 is patiently waiting for its day in the sun, which is going to happen right now. So I have x squared plus 6x. 9 minus 2 is 7. And there we go. All right, I'm going to flip to the last page. That's those 4 problems. That's the hardest part of the day. The last bit is just a few more composition problems that you might see with the values given to you in different ways. So just for time's sake, I'm going to have you do this. I'm hoping that you can read graphs. So what I would like you to do, please, is let's do this one with, which one do I want to do? Options. Let's do graph 2. So what I would like you to do is do the 3 problems for graph 2. You're finding the compositions and you're getting the values from the graph. Right, so the first one is f composed with g of 2. So I've rewritten that in f with the g of 2 inside. That was my first step. So now I'm going to use the graph to figure out what g of 2 is. So here is the x value 2. I'm just doing in green. So the g value is 1, 2 down. So that is negative 2. You with me so far? And now I do f at that value, negative 2. So now I go back over here to negative 2. I'm just going to make a little mark so I know where I am. And I'm going to see what is the value of f. And that is 1, 2, 1, 2, 3, 4 down. So that ends up being negative 4. The next one is g of f of 4. So I've rewritten that with my notation, g and then f of 4 inside. So I'm going to go to the value 4. This time I've got a pink pen. So here's the value 4. And so the value of f there is 1, 2 up. So that means this is g of 2 now, because the value of f of 4 was, we just saw, to be 2. And now I'm going to go to 2. I've already got a mark there. Let me make a little pink mark on top. And I want to know what g of 2 is. Well, that is 1, 2 down. So that's negative 2. Last problem on this little set of problems is, hopefully didn't confuse you, but it's the same sort of thing. We're composing g with itself. That is a thing. So here we go. I've got g composed with g of 0. So I've got a g on the outside, a g on the inside. You're using the same function this time twice. So g of 0, that's going to be my first thing. So here's the x value 0. Got a little orange mark. G of 0 is 1, 2 up. And so the only difference this time is now, instead of looking to the other function, I look to the same function again, and g of 2. And that seems to have popped up on every example, so I wasn't super creative. G of 2 is 1, 2 down, so that is negative 2 again. Before we hit our last example, go to the example on the right and do the middle one, g composed with f of negative 1. We're doing this one right here in the middle, g composed with f of negative 1. All right, so g composed with f of negative 1, let me rewrite that. That's g composed with f of negative 1. So there we go. So now I'm going to go up to the graph. I'm going to look at what the function f is at negative 1. So here's negative 1. And what do we notice about the function f at negative 1? There is no function f at negative 1. The function f is the square root function. It's over here. So I'm going to write that this then is undefined. All right, our last couple problems are just like those problems. I'm just giving you the different looks you're going to see. This time, instead of an equation or instead of a graph, I gave you 2 tables. So let's go ahead and just do the first one to see how you do with it, reading the table. Sometimes this gets a little goofy. So f composed with g of 3, please. Okay, so I've rewritten this as f and then g of 3 inside. So I'm going to have f, and then I've got to put the value of g of 3. So I go to the table for g. G of 3 is right here. So the y value, the output for that is -2. Okay, so here's the 3, and we get -2 out. And so now I go to the function f at -2, and the function f at -2 is this right here, -2. What I get out is 1. Okay, so do the next one down, g composed with f of -2. Okay, so g composed with f of -2. First thing is I need f of -2. Well, we just saw that. We've got this one circled over here. F of -2 is right over here, and so we get the output of 1. So this time it's g of 1. And g of 1 is equal to, I go down to this table, g of 1's right there, and my output is 2 that time. All right, last problem for the day, and then just a couple quick things to tell you before you pack up and run out of here. So do that very last one at the bottom. Okay, so f composed with f of 4. So first thing I've got to do is figure out what f of 4 is. So I go up here, and f of 4 has an output of 2. And then I go back to the table because we're using the same function. I've got f of 2, and f of 2 is right here. So my output is 3. And there we go. There's our function composition.